Hello everyone, in today's video we are going to cover the law of sines. After studying today's section, you'll be able to use the law of sines to find missing side lengths and angle measures of any triangle. Our trig ratios have allowed us to find side lengths and angle measurements in right triangles. The law of sines will allow us to find side lengths and angle measurements for any triangle. The law of sines shows the proportional relationship between angles and their opposite sides. Again, we can use it to find side lengths and angle measurements for any triangle. So for a given triangle ABC, the law of sines states that sine of angle A over side A is going to be equal to sine of angle B over side B, which will also be equal to sine of angle C over side C. So the law of sines tells us if we're given different angles and sides, I can set up proportions relating these angles with their sides to find missing angles and missing sides. Looking at our sample problems, we're going to use the law of sines to set up a proportion and solve for x. Looking at number 1, I have side lengths of 12 and x and angle measures of 71 and 35. So the law of sines tells me I need two angles and their sides opposite. I set up a proportion of the angle and the side opposite is equal to the angle and the side opposite. So 71 is opposite side x and 35 is opposite side 12. So I could set up my proportion of sine 71 over x is going to be equal to sine 35 over 12. Now I will just solve this for x. So I would multiply by 12 and by x. So I'd get 12 sine 71 is equal to x sine 35. I will divide everything by sine 35 to give me x is equal to 12 sine 71 over sine 35. When I plug this into my calculator, I get a side length of 19.8. So my missing side length here is 19.8. Now looking at number 2, I have side lengths of 5 and x and angle measures of 114 and 18. X is the side that is opposite of 114 and 5 is the side that is opposite of 18. Setting up my proportion, I would have sine of 114 over x is equal to sine 18 over 5. Now solving this in terms of x, I'd multiply by x and 5. 5 sine 114 is equal to x sine 18. Dividing everything by sine 18 would give me x is equal to 5 sine 114 over sine 18, which when I plug this into my calculator, I get a missing side length of 14.8. Looking at number 3, we have angle measures of 73 and 59 and side lengths of x and 20. 20 is the side that's opposite of 73. X is the side opposite of 59. Setting up my proportion, I'd have sine 59 over x is equal to sine 73 over 20. Multiplying by x and by 20 would give me 20 sine 59 is equal to x sine 73. Dividing everything by sine 73 would give me an x value of 20 sine 59 over sine 73. Plugging this into my calculator, I would get x is equal to 17.9. Looking at number 4, I have angle measures of 53 and 96, and then side lengths of x and 27. Now 96 is the angle that is opposite side 27. 53 is opposite this, which we could call y, but I'm not looking for that. I'm looking for x. So I can use these two angle measures and the fact that I have a triangle to find this angle measure here. So 180 minus 96 minus 53 would give me 31. Now I have the angle measure that's opposite side x, so I can set up my proportion. I would have sine 96 over 27 is equal to sine 31 over x. Multiplying by 27 and x, I would have x sine 96 is equal to 27 sine 31. I would divide everything by sine 96. So x is equal to 27 sine 31 over sine 96, which would give me a side length of 14. So if I don't have one of the angles that's opposite a side, I can use the fact that I have a triangle and two angles, subtract those two angles from 180 to give me the missing angle. Next, looking at finding angle measures. Number 9, we have side lengths of 9 and 14 and angle measures of 77 and x. 9 is the side opposite of x, 77 is the side opposite of 14. So I'd set up my proportion here where I have sine x over 9 is equal to sine 77 over 14. Now I'll multiply by 9 on both sides to get sine x is equal to 9 sine 77 divided by 14. To get rid of the sine, I'm going to take the sine inverse. So I'd multiply everything by sine inverse. So 9 sine 77 divided by 14 will be sine inverse of 9 sine 77 divided by 14. Now, when I plug this into my calculator, I'll get an angle measure of 38.8 degrees. Looking at number 10, I have angle measures of 126 and x, sides of 15 and 31. X is the angle measure across from 15, where 126 is the angle measure across from 31. So sine x over 15 will equal sine 126 over 31. Multiplying by 15 on both sides, I'll get sine x is equal to 15 sine 126 over 31. Multiplying by sine inverse, I would get x is equal to sine inverse of 15 sine 126 divided by 31. When I plug this into my calculator, I'll get an angle measure of 23 degrees. In today's lesson, we learned we can use the law of sines to find side lengths and angle measures of any triangle. Remember, the law of sines is sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. That's a wrap on today's video. We'll see you in the next one.